This is our lesson for section 6.3. It's on angle bisectors of triangles. So you should know what an angle bisector is. If you bisect something, that means it splits it in half. So an angle bisector would be like that red ray. It's going to go through the middle of an angle. And we know that it goes through the middle of an angle because of these marks. These congruent arcs indicate that these two angle measures are exactly the same. So if this bisects an angle, you know these match. So anytime you see this statement, ray PS bisects angle QPR, notice what angle QPR is, that big brown angle, that makes this problem really, really easy because these two parts are the same. So you know these two little angles, angle QPS and angle SPR, are congruent. So that means their measures are the same. That's a review. Now what we're going to do is use the same concept, except go with an angle bisector of a triangle. So triangles have three angles. Just pick one of them and bisect the angle. So you're going to have a segment that goes from a vertex to one of the sides opposite of it, and those two angles are congruent. Now, here's what you got to watch. This point does not have to be a midpoint. Most of the time, it's not going to be, because what you're doing is you're setting it so that these angles are congruent, not so this is the midpoint. So this segment AB is an angle bisector of triangle DAC. So you know that angle DAB, that's this little guy here, and angle CAB, that's this little guy over here, are congruent. So their measures are the same. So here's all of our special segments for triangles, all on one slide. These are things about medians, altitudes, perpendicular bisectors, and angle bisectors, all located in one place. So an angle bisector can be a ray or a line segment, and it's going to bisect the angle of a triangle. Here's an easy example. It's only easy if you understand how to read this. So in triangle MNP, that's this big triangle right here, segment MO, that's the red one, bisects angle NMP, that's this angle right here. So if it bisects it, what does that mean about angle 1 and angle 2? It means they're going to be congruent. If angle 1 is 33 degrees, that's its measure, find the measure of angle 2. Well, this one's 33. What's this one if it gets bisected? It's going to be 33 degrees as well. What about the measure of angle NMP? That's the big angle. It's a combination of two 33-degree angles. So it's 66 degrees. That's an easy example. Here's another easy example. Different triangle. Now it's triangle PQR. Segment QS, that's the red one, is going to bisect angle PQR. If the measure of angle PQR is 70, so this whole entire angle is 70. So I'm going to make a little bracket kind of thing. That entire angle is 70. But we know that this angle gets bisected by that red ray. So if the whole thing's 70, what are the two little pieces? So last time, we took a little angle times 2 to get the big one. Now we have the big angle. Let's take that big angle divided by 2 to get your two little angles. So these two little guys are each 35 degrees. So when you see that word bisects in a problem, that means it's going to be really easy to find your answer. You're either going to multiply by 2 to get the big one or divide by 2 to get one of the small ones. We'll look at the tougher example in the next video.